Located along the valuable banks of the River Thames, Battersea Power Station was once an industrial giant that released thick black smoke, consuming thousands of tons of coal every day to supply up to 1/5 of all electricity for London. Yet today, this magnificent structure had nearly become nothing more than a colossal shell on the verge of collapse. However, instead of demolishing it, one of the largest regeneration campaigns in European history, lasting 12 years and costing £9 billion, was launched. More than 4,000 engineers and workers dismantled and then rebuilt all 4 iconic chimneys, standing over 100 meters tall, reconstructed an entirely new multi-level spatial system inside the massive hollow interior of the former power station, and extended a new underground line stretching nearly 3 kilometers directly to the foot of the structure. In today's video, join Mandarin Tech as we decode one of the most intense mega construction sites of the 21st century. Battersea Power Station. Battersea Power Station was once one of the largest and most important coal-fired power stations in the United Kingdom, constructed in 2 phases from the 1930s to the 1950s along the banks of the River Thames, a strategic location that allowed coal to be transported directly by water into central London. At its peak of operation, the facility supplied up to 1/5 of the electricity for the entire capital, becoming the energy heart of a city entering a period of rapid modernization. However, after it completely ceased operations in 1983, Battersea Power Station quickly fell into severe deterioration. The roof was removed, the interior of the Turbine Hall was almost entirely emptied, and the massive structure faced the threat of demolition after decades of failed redevelopment plans. For nearly 40 years, it stood as a forgotten industrial symbol in the heart of London. It was not until 2012, when a redevelopment plan worth nearly £9 billion was officially launched, that Battersea Power Station truly began its journey of transformation. This was not only an effort to rescue a decaying architectural landmark, but also an ambitious vision to create a mixed-use mega-urban district covering 42 acres along the banks of the River Thames. The structure, covering approximately 260,000 square feet along the banks of the River Thames, will be completely reconfigured to serve new urban functions. The massive boiler house will be converted into 6 levels of modern office space, combined with residential units and large-scale event spaces. The 2 turbine halls, which once housed the enormous power-generating machines, will be transformed into multi-level retail areas. Meanwhile, the 2 switch houses at either end of the building will be converted into more than 200 high-end apartments. Most notably, the 4 iconic chimneys of Battersea will be entirely rebuilt, with one chimney incorporating a modern glass elevator that allows visitors to observe panoramic views of London from a height of more than 100 meters. Amid all of these massive reconstruction works, the dismantling and complete rebuilding of the 4 white chimneys, each approximately 103 meters tall, became the most complex technical challenge of the entire project, as these were also the structures that had deteriorated most severely after more than half a century of operation and nearly 30 years of abandonment. During structural inspections, engineers discovered that the outer concrete shell had developed deep cracks, the internal reinforcing steel had corroded, and the load-bearing capacity no longer met modern safety standards. As a result, they were forced to dismantle the chimneys entirely and rebuild them from the ground up, rather than reinforcing them in sections. Unlike conventional industrial chimneys that can be demolished using blasting methods or mechanical dismantling from the base of the structure, Battersea is located in the middle of a dense residential area along the River Thames. Therefore, the construction team had to apply a top-down sequential dismantling method using a full-height scaffold enclosure surrounding each chimney to control vibration, dust, and falling debris. After the removal of the original structures, the 4 new chimneys were rebuilt using modern reinforced concrete. However, in order to strictly comply with heritage conservation regulations, the engineers effectively turned back the clock and precisely replicated the construction methods of the 1930s. Instead of using high-capacity concrete pumping systems, as in modern tower construction today, materials were lifted upward using hoists and transported manually by approximately 25,000 wheelbarrows of concrete, then poured into circular formwork in successive rising stages. This process recreated the characteristic horizontal banding visible along the chimney shafts. A seemingly small detail, but one that played a crucial role in restoring the original appearance of Battersea. Finally, more than 400 gallons of specialized protective coating were applied to the exterior surfaces, increasing resistance to moisture penetration and weathering in the riverside urban environment. As a result, the four chimneys today are almost impossible to distinguish from the originals with the naked eye, even though they have in fact been completely dismantled and entirely rebuilt. After restoring the outer shell, the engineering team moved on to one of the most complex mechanical tasks at Battersea Power Station: installing a passenger elevator inside the core of a chimney. The challenge lay in the fact that the chimney was not a perfectly vertical cylinder. It was designed to be wider at the base and gradually narrower toward the top, while the elevator's guide rails had to remain absolutely vertical. In addition, if the motor were placed at the top, as in conventional designs, the heavy load would affect the structural integrity and completely obstruct the glass observation ceiling. To solve this problem, Battersea's engineers adopted a solution inspired by the Hammerschwand outdoor elevator in Switzerland, built in 1905, reversing the entire drive system. Instead of placing the machinery above, a hoisting machine weighing about 7 tons was installed at the base of the chimney. The system operates using a looped cable configuration. The cable runs from the ground-level motor up to a massive reinforced steel ring at the top of the tower, then loops back down to connect with the cabin and counterweight. This design removes the heavy load from the top of the chimney while preserving a completely unobstructed glass ceiling view. At the same time, to address the tapering shape of the chimney walls, the guide rails were not fixed directly to the inner concrete surface. Instead, they were mounted on adjustable support brackets that compensate for the wall's inclination and create a perfectly vertical travel axis. As a result, a transparent glass dome cabin, capable of carrying about 30 passengers, can rise to a height of 109 meters in just 26 seconds, forming a unique observation experience inside the historic chimney. With an area equivalent to about 96 tennis courts, a structural frame made up of more than 8,000 individual steel components, and an exterior envelope constructed from nearly 6 million bricks, Battersea Power Station is one of the largest brick buildings ever constructed in the world. However, after many decades during which the roof and most of the floor systems were removed while the building stood abandoned, the structure was effectively reduced to a vast hollow shell. This meant that engineers were not simply renovating an existing building, but were almost entirely constructing a new structure inside a heritage shell nearly 100 years old. The engineers decided to insert 14 new structural floors within the industrial volume that had originally housed only turbines and power boilers. However, a major contradiction emerged. The upper levels designated for offices and residential apartments could rely on conventional column support systems, while the retail and event spaces below had to remain largely open and uninterrupted, without dense structural columns occupying the usable space. To solve this challenge, the engineers adopted a solution familiar from the history of skyscraper construction: wide-flange steel beams designed to resist large bending forces, a structural type that contributed to landmark projects such as the Empire State Building, the Chrysler Building, and Rockefeller Center in New York. At Battersea, specially sized transfer beams were installed to create new intermediate floor levels. One of the most critical elements was a steel beam measuring 27 meters in length and weighing about 62 tons, which had to carry the load from 8 floors above, with the total transferred force exceeding 2,000 tons, while there were no direct supporting columns beneath it. At the same time, engineers implemented a special structural system known as a steel transfer tree. In this configuration, a large column below functions like a trunk, branching into several smaller members that receive loads from the office columns above and channel them into a single supporting point. As a result, Battersea was able to maintain wide column-free retail spaces at the lower levels while maximizing usable floor area for offices and residential units above. Although the mechanical core was removed after the power station closed in 1983, the tens of meters high volume of Turbine Hall A was preserved almost entirely intact and transformed into a commercial grand hall, while strictly maintaining the architectural proportions, column system, and industrial steel roof structures overhead. Particularly significant within this scope of work was Control Room A, the central control room of Battersea Power Station, which was restored in the 1930s Art Deco style. The stone-clad control panels, mechanical switches, load meters, and original finish layers were carefully dismantled, cleaned, restored, and reinstalled in their exact original positions according to historical archival records. As a result, the building today preserves not only its external architectural shell, but also the historic operational center of the entire power station inside. One of the most important infrastructure components of the entire Battersea Power Station project was not located inside the building itself, but beneath the ground of London, the extension of the Northern Line by approximately 3 kilometers to directly connect this area with the central city underground network. Before the project began, Battersea was a riverside area that had almost no direct metro connection, making the development of a large-scale urban complex here nearly unfeasible from a transportation perspective. As a result, 2 new stations, 9 Elms and Battersea Power Station, were constructed as part of the first London Underground extension project in the several decades. The tunnels were excavated using tunnel boring machines, passing through the characteristic London clay layer beneath a densely built urban environment, while the Battersea Station itself was positioned immediately adjacent to the base of the former power station structure. Thanks to this connection, Battersea Power Station was no longer an isolated riverside industrial site, but became a new urban center directly integrated into the modern underground transport network of London. After more than a decade of continuous construction, Battersea Power Station entered its final critical phase, comprehensive operational testing before its official opening in 2022. This was not simply the acceptance process of a single architectural structure, but the coordinated testing of an entire urban complex built within the shell of a nearly 100-year-old power station. In just the first 12 months after opening in October 2022, Battersea Power Station attracted more than 11 million visitors, quickly becoming one of the most visited new urban destinations in London. During the opening weekend alone, approximately 250,000 people came to the area within just the first few days of operation. The retail spaces, restaurants, and experience areas inside the former power station were rapidly filled with more than 120 shops, dining venues, and services, while the Lift 109 elevator system alone served tens of thousands of visitors shortly after beginning operation. Today, Battersea Power Station is no longer an abandoned power plant on the banks of the River Thames. It has become an urban center operating 7 days a week, attracting millions of visitors each year and serving as a new development engine for the entire 9 Elms district. The clearest evidence that an industrial icon of the 20th century can be reborn as an economic and tourism destination of the 21st century. After nearly a century of existence as one of the most important power stations in London, Battersea Power Station has undergone a transformation rarely seen in the history of modern urban regeneration. From an industrial icon that once supplied electricity to millions of residents of the capital, then left abandoned for several decades and facing the risk of disappearing entirely, the structure has been revived through one of the most complex restoration projects in Europe. What makes Battersea truly remarkable is the construction of an entire city inside the shell of a nearly 100-year-old power station. Each of the iconic chimneys was dismantled and rebuilt. Each turbine hall preserved in its historic structural form while integrating modern functions, and major infrastructure, such as the Northern Line, was extended to the site to transform it into a fully connected urban center within London. Today, Battersea Power Station is not only a heritage restoration project, but also a representative example of how a 20th century industrial structure can be reborn as a dynamic urban destination of the 21st century. If you would like to explore more world-class mega-project construction sites, don't forget to subscribe to the Mandarin Tech channel so you won't miss the upcoming videos.